Ladies and gentlemen, it is our pleasure to welcome you to the 3.14th Calculympics. We are your hosts,
Susie Mishkin
and Lauren Ward, here to give you a play-by-play of one of the most exciting events in the mathematic world.
Today's Calculus Olympics consist of 3 events: separation and integration, the downhill slope field curve, and the dreaded baked potato challenge. Seems like we'll have quite a day ahead of us.
At this time, we'll introduce you to the official Calculympics scoring system, loosely based on the classic Euler's method.
The winner of each event will use the dy dx equation shown in the black to add points to their score. The losing mathlete will instead receive an automatic dy dx of 0, thus adding no points to their score.
Now that we've covered our bases, let's get on to the first event.
This is, of course, the classic separation and integration biathlon. The first section requires the competitors to successfully move x and y components of the given differential equation to opposite sides of the equal sign.
Then, in the second half, they will find a particular solution using an initial condition. The initial condition they are working with today is f of 2 equals 1.
Our first competitor has separated the equation, setting a record-breaking pace, and now moving on to the integration portion of the equation.
I'd say that's looking pretty good so far.
Yes, it is. Good weather we're having today, isn't it?
Yes, it is, isn't it? It's nice and balmy. Okay, the competitor seems to be wrapping this one up, but hold on here. Is she going to forget to solve for c?
I believe so. That is the entire point of the initial condition. What a rookie mistake.
That is too bad.
Ugh, what a disaster.
Now, if competitor 2 can correct this mistake, they will get the points and sweep this event.
Let's watch and find out.
This is a very tense moment in the first event of these Calculympics.
Now the trick is not only to find c, but to calculate it correctly and add it back into the equation. Can she do it?
We'll see. Only time will tell.
Oh, she's found c.
Can she do it? Can she bring it home?
Yes! She did
it! A success!
Now to quickly tally up the scores after the first event, and a quick reminder, this is loosely based on the Euler's method and is not an exact replication.
Yes, normally the equation of dy dx itself does not change, but for our purposes we are making an exception.
Going on to the second event, contestant 2, shown by the green table, is taking the lead.
Now a message from our sponsors.
And now, up next, the downhill slope field curve.
All the contestants have to do here is to draw the correct curve going through the given point on the slope field.
This may seem easy, but we have seen many an Olympian scores go downhill after this event.
You know, I really thought we weren't doing the puns this year.
And as the contestant successfully wraps up their turn, we move on to contestant number 2.
Now, after such a good example, this should be a piece of cake.
Competitor 2 should slide through this event.
Seriously, no puns. Do I need to call in station management?
You think my puns are bad? Well, check out this curve contestant 2 just drew.
Oh, I haven't seen a mistake this bad since Steve the Slope Johnson in '94. That is going to be detrimental.
Yes, as we see a 0 being added to her score.
Competitor 1 goes straight into the lead, but will it be enough to last through the third event?
Up next is the grand finale, the baked potato application problem, right after a quick public service announcement. Cut to our potato, where the initial conditions are being made and measured.
Now, given the initial temperature and the dg/dt equation, which is the rate of change in temperature, each competitor will be asked to find the temperature of the potato at time t equals 4.
All coming down to the wire in this final event.
So contestant 2, starting off this time as the loser of the last round.
She appears to have taken the integral of the rate of change function given, and that seems to be correct so far.
So the approach she's going with here will be to use the initial condition to find C, like in the first event, if you'll recall, then substituting t equals 4 for the final answer.
This seems to be a solid approach.
Indeed it does.
This tends to be quite a lengthy event, so for your convenience, we have sped up the footage.
Wrapping up the math, we go to contestant 2's final answer, which is correct.
Now, competitor 1's turn, taking a different approach, opting to use the limits of integration from 0 to 4 instead.
Now this is a completely viable approach as long as she remembers to add the initial condition, or else she will have only found the amount the temperature has changed instead of the temperature at time t equals 4.
Let's see what she does. Oh, is she going to? Oh, and she forgot to add the initial condition, costing her the points.
What's more, that would be an extremely cold potato.
So we finally are tallying up the final points, and the winner is...
Contestant number 2 is the champion of these 3.14th Calculympics. It has been a wonderful day of math and sport. Thank you for joining us, and we will see you next year.